Hello. Hi to everyone. Next we are moving to the next chapter, chapter number 5, Transistor Characteristics and Approximation. This is the first lecture on that. So we'll discuss in this particular lecture number 1, characteristics of common base, common emitter and common collector characteristics. Okay. So see here, transistor static characteristics. So in the case of transistor characteristics, we have three types of characteristics we have to discuss. The first characteristics is the input characteristics. So input characteristics. The second one is output characteristics. Third one is a constant current or transfer characteristics. Okay, transfer characteristics. These are the three characteristics we are going to discuss each and every case. So first we'll start with the common base test. Okay, common base transistor characteristics. In the common base transistor characteristics, first you are identify that we have connected the input voltage, that is a variable voltage, as well as output voltage, it is also variable voltage. As well as we are going to connect the voltmeter across the base emitter and base terminal, as well as emitter terminal connected in series with the 1 ammeter. Here also 1 ammeter is connected in series with the collector terminal, as well as voltage across the collector and base terminal you are connected to voltmeter. These are the meters we are going to connect. Already in your laboratory we did these experiments. Now I am going to explain how exactly the graph will be there. In the examination point of view, what is required, I am going to explain to you. It is very useful for your attending the it means that it is very useful to answer the questions in the examination. So these are the parameters you are going to connect. So now the case here, while you are doing the characteristics, the first we'll see the input characteristics. Input characteristics is nothing but what about the input currents here? The input current, the input parameters, the input characteristics is nothing but the graph drawn between the input current. What is input current here? IE. IE is the input current. So IE is the input current. Next, what about the input voltage? VBE, because it is in between emitter and base. So VBE is a input voltage. So what the question you may expect that in case of common base characteristic, the input characteristics drawn between, they will ask the question, drawn between what? Emitter as well as the VBE, the voltage across the base and emitter, that is the input current versus input voltage. So the input current versus input voltage, look at here, the input current, the input terminals are emitter and base, which the transistor here, the transistor is a NPN transistor. NPN transistor. In the case of NPN transistor, it is act like a only you are consider input only one junction, that is like act like a diode, right? Because it is a only one junction, NPN, that is a junction we have PNP or NPN junction, only one junction is present. It is look like a diode. So the characteristics also look like a diode because you have considered the input voltage. So we'll see how exactly it is these particular characteristics are obtained. The first, the make it output voltage, that is a VCB, is constant, that is the first condition. So for certain value, so VCB is a constant. After that, VBA, input voltage VBA, what we given VBA is increases step by step. VBA increases step by step. Okay, VBC increases step by step. Whenever increases step by step, what will happen? IE is increases. initially because diode some barrier potential is required to overcome and to change in the conduction mode, so it is not allowed initially. But once, for example, it is a germanium, once it reach the cut-in voltage, so once it reach the cut-in voltage, germanium start to conducting. This is the characteristics. Gradually it is increases the current value. So this is a VCB step by step. We are going to plot this particular character. In case of silicon, the cut-in voltage is different here. So plot these characteristics in between IE versus VBE. Got my point? So this is the way they plot the characteristics. For example, if VBE is equal to 0, you will get 0. If VBE equal to 1 volt, you will get somewhat 2 volt, 3 volt and 4 volt up to the saturation value, up to the some certain value. Where increases, the graph will be linear after a certain value. So by using this particular graph, we are going to calculate the input resistance. How to calculate the input resistance? Change in voltage VBE divided by change in current, emitter current. So the condition here, VCB or VCB is constant. VCB is a constant. That is about the input characteristics. Everyone is clear about the input characteristics, I guess. Okay. Next we are moving to the output characteristics. In the output characteristics is drawn between output parameters. First identify what are the output parameters we have. The output parameters here, the collector current IC and then voltage VCB. So that means that output characteristics is drawn between what are the parameters, VCB versus IC, collector current. So it is drawn in between VCB versus IC, collector current. But which parameter is constant here? The input current. So emitter current is constant. That is important. So if emitter current is a constant, then you can plot the graph between the VCB and the IC, will get the output characteristics. Okay. So what exactly the characteristics will happen, we'll see. So now what I am doing, I am keeping the input VE, the input voltage. Whenever I am keeping some input voltage, what will happen? IE is also maintain some value. That means that I want to adjust this particular variable terminal, the potentiometer, whenever I vary this particular current, particular voltage to maintain the constant of IE. For example, IE maintain 1 volt, 1 ampere, 1 milliampere otherwise. Whenever IE maintain 1 milliampere, that keep it 1 milliampere, and then we can start from here. VCB increases step by step and plot the current value. So got my point? So what I am doing now, IE, for example, initially IE is equal to 0, I make it. Whenever IE is equal to 0, that means that emitter is open. Whenever emitter is open, already mentioned. Okay, emitter is open, already mentioned. Whenever emitter is open circuited, leakage current will be flowing. From the last chapter, transistor basics, I explained that. So emitter is open circuited, even though some current will be flowing. So then I will increase the value of VCB. I increase the value of VCB step by step. What will happen? Some leakage current will be flowing. That leakage current will be maintained constant up to saturation, up to cutoff region. Once you exist the VCB value more than that, so transistor going to be conducting. It is going to be breakdown. It is going to be entering into the breakdown region. Got my point? That means that you can apply up to safe value. Before breakdown value only you can consider. Whenever this IC is equal to 0, what about this current? Particular current is a leakage current. This is the reason below the leakage current. This is the reason is a cutoff region. That means a transistor we have a cutoff region, saturation region, as well as breakdown region. These are the three particular. Okay, these are the three particular regions for the transistor graph output characteristics. So now the case we have second case. I want to maintain now IE is equal to 2 milliamperes. I make it to input voltage varying, then make it to IE is equal to 2 milliamperes. I make it IE is a constant now. I am going to keep on increasing VCB step by step. What will happen? Again, it maintains some constant current, i.e. collector current is also constant. Once it reaches to the more than the breakdown voltage, the current will be suddenly increases. So this is the active region. This is the active region. So now keep on, you are increasing different 4 milliamperes, 5 milliamperes, 8 milliamperes. This particular graph will be appear. This is the output characteristics. Okay. So this is a very important. After that, in this case we are going to find out the output resistance. Previously you are going to find out the input resistance. Now output resistance is a change in voltage, VCB, change in voltage divided by change in current. Then we will get the output resistance. It is a 1 by slope actually. So we are also calculating the one more important point in the output characteristics. We are also can identify with the help of this particular output characteristics leakage current. ICB is a leakage current. You can also do that. After that, this particular character, with the help of this particular characteristics, we can also find out alpha DC, that is a current gain. So current, how to find out the current gain? IC divided by IE is a current gain. You can also find out with help of that. So this is about also study about the another point, study about avalanche breakdown. Okay, rapidly due to the current will be increases. You can also study with help of this output characteristics. These are the points are enough to for output characteristics of common base. So then we are moving to the next one. Next characteristics here, transfer characteristics, third. So transfer characteristics we'll see. So current transfer characteristics are constant characteristics, also here call it as a current transfer characteristics. In the current transfer characteristics is drawn between the first point IC versus IE. So current transfer characteristics is drawn between IC versus IE. So IC versus IE, these are the currents, emitter current versus collector current. So how the emitter current versus collector current, which parameter going to be constant? You should maintain VCB is a constant. So what is the VCB? Look at here in the circuit. VCB is the output voltage. The voltage across the collector and base voltage should be constant. You should maintain that particular thing is constant. Then I just first you are giving some input current. Okay, that means that IE is equal to 0. What about the collector current is equal to 0? Just keep on increasing the IE value. The collector current also increases linearly. Okay, the change in collector current and then change in emitter current, change in collector current and change in emitter current. That means that its value slope is given current gain. Current gain is equal to change in collector current divided by change in emitter voltage. Change in emitter current. This is about the current gain. So after that, for example, the transistor have some leakage current. Initially, whenever we are increasing the emitter current, whenever emitter current is equal to 0, even though it is a collector current is not 0, some amount of current will be present, that is a leakage current due to the minority charge carriers. So this current is a leakage current. Due to this leakage current, now we are increasing the emitter current, the graph will be like that. Okay, in this case also VCB is a constant, very important. So we have this is about the transfer characteristics. So in the examination, what we may expected, the output characteristics is drawn between, they will ask the question, it is drawn between output voltage versus output current, that is a VCB versus IC in case of common base configuration, as well as input characteristics in case of common base configuration. We are going to draw in between IE versus VBE, as well as the transfer characteristics is drawn between input current versus output current. So that's what common base test. Coming to the common emitter test. So second one is a common emitter test. So what I explained previously, the same procedure here also, the characteristics. That's why I will explain quickly all remaining two, common emitter test as well as common collector test. So now we are moving to the common emitter test. Look at this diagram, again same thing, variable voltages too, as well as here in this case the base is connected to 1 ammeter, collector is connected to 1 ammeter, and then output collector versus emitter connected the voltmeter. That is the difference, because it is a emitter is a common to the both input and output. So here also three characteristics. The first one is a input characteristics. We have to discuss input characteristics as well as output characteristics, and then third one is transfer characteristics. Okay, so let us discuss one by one. So common emitter static characteristics is the first input characteristics we are going to discuss. The input characteristics, first identify the what are the input currents we have. The input currents is IB as well as input voltage is VBA. So the input characteristics is drawn in between IB versus VBE in case of common emitter configuration. So the input characteristics drawn between VB versus IB versus VBE. So which parameter going to be constant? In the previous case also output, that is a VC is a constant. So output voltage is a constant. VCE is a constant. We have to do that. So constant at constant VCA. So now what I am doing, VBE is increases step by step. So it is the same as already mentioned, same as diode characteristics. Input characteristics is similar to the same as diode characteristics. That may be chance question is there, chance will be there. In case of transistor characteristics, one of the input characteristics is similar to the dash element, diode, diode, otherwise FET, UJT, none of the above. You can pick up the answer is a diode. So now initially VB is equal to 0, IB is equal to 0. We are increasing the gradually VBE. What will happen? Gradually it is increases the value of the base current. This is the base current value. So in the previous case the slope is not much, but here slope is very much, because IB is a base current. Base terminal is a very thin layer and then very narrow width, compared to the previous case emitter versus in the previous the characteristics here IE versus VBE. In this case slope is very less. Maybe it is a suddenly it is increases linear, almost linear. Why? What is the reason behind? Because in case of common base configuration, the base in case of common emitter configuration, the base current you are taken as the input. So base terminal very less, that means that very thin layer, lightly doped. So that's why it takes some time to reach the maximum current. So slope is more. Okay, anyway, now what happened, this particular characteristics, we are going to calculate the input resistance same as change in voltage VBA divided by change in current IB. Okay, held VC is a constant. Okay, then this is what input characteristics. Then we are going to the output characteristics. In the output characteristics is drawn in between output current, that is IC versus output voltage VCE, but base current, that is IB is a constant. So characteristics is drawn between VCE versus IC. So keeping IB is a constant. This is what you need to do that. So after that, I make it the initially VC is equal to 0. Whenever EC is equal to 0, what about the collector current is starting from 0. Whenever VC is equal to whenever I maintain IB, initially IB is equal to 0 in the first case. Whenever IB is equal to 0 is nothing but a input is open circuited. When our input is open circuited, what will happen here? Leakage current. Just now we discussed about the leakage current VCEO concept. So leakage current will be generated. Due to the minority charge carrier, some very small amount of current will be flowing, and then once you reach the cutoff region, so transistor going to be breakdown, it will enter into the breakdown region. Clear? This is a cutoff region. This particular region is a cutoff region. This is a breakdown region. This is a saturation region. Okay. Now see here. This is the active region actually. Okay. Now see here, cutoff region. This is the ICEO leakage current. Now what I am doing that IB increases to 20 milliamperes. Whenever IB increases 20 milliamperes, this value increases 20 milliamperes. Now I make it VC is equal to 0, VC is equal to 1, 2, 3 volt up to we are increasing certain value. Once it is breakdown, again transistor going to be output current going to be increases suddenly. Once it is entered. Okay, same thing what will happen 40 as well as 60 and 80 milliamperes and gradually increases the base current. Once increase the base current, that particular value, but particular 40 milliamperes should be constant, and then again conduct the experiment. Again repeat the same process. Adjust to 60 milliamperes the base current. Again step by step increase the voltage. That way you are applying this particular characteristic. So again beta DC, that is a current gain, we can also find it as delta IC divided by delta IB. Okay. After that, transfer characteristics of a common emitter configuration. So it is drawn between the input current, that is IB, versus output current IC. So what parameter should be constant? Output voltage, that is a VC, is a held constant. So initially IB is equal to 0. Even though IB is equal to 0, some leakage current will be flowing. So after that the gradually increases the graph. Here leakage current, constant leakage current, and then the same thing VC is a kept what we call constant, and then IB is gradually increases step by step. IC is also increases linearly. So with help of these characteristics, ICEO is equal to 1 plus beta into ICO. From this graph we can do that this is a leakage current value. So this leakage current value obtained from IB is equal to 0 in the initial case. IB is equal to 0. So beta DC or beta AC, the change in current divided by change in voltage, change in base current IB, when the VC is a constant. That is a condition we have. This is about the current transfer characteristics of common emitter. So coming to the common base characteristics, common collector static characteristics we are going to discuss, but I will discuss the common collector characteristics quickly, because what the characteristics appeared in the common emitter, the same characteristics here also, the same thing is happened. That's why it is not required to explain each and everything. Just I will conclude with help of the common emitter. So in the examination also, common emitter characteristics is similar to the common collector characteristics. Both are similar. Now here same thing, common emitter terminal should be common collector should be connected to common from input and output. We are connected one ammeter, voltmeter, ammeter and voltmeter here. So in this particular case also we are going to draw the three characteristics. So the first characteristics is the input characteristics, output characteristics, as well as transfer characteristics we are going to draw. So the first one, you are moving to the let it be the input characteristics. Next, second, output characteristics. Third one, transfer characteristics. Okay, first we'll see the input characteristics is drawn between input current as well as input voltage, right? So what about the input current and input voltage? Input current is IB, input voltage is VCA. which parameter should be constant? The output voltage VC is a constant. So see here, VC is a, for example, VC is here given 2 volt. Okay, VC is given 2 volt. So initially VC is equal to 0. That particular current IB is equal to 0. Whenever it reaches to the cut-in voltage, then diode will be, that particular transistor will be conducting. This is the characteristics. Whenever increase the VCE further, the cut-in voltage more than increases, and then we are going to obtain this particular characteristics. This is the input characteristics. As well as, output characteristics is drawn between what are the parameter output voltage as well as output current. What about the output voltage? The output voltage is VCE, output current is IE. So initially what parameter should be constant? The input current, that is what about the input current here? IB should be constant. So IB is a constant. Now VC is equal to 0, IE is equal to 0. So you increase the VCE and then you will get this particular thing. After that we are giving IB is equal to 20. You will get this particular relation. So we are keep on increasing this particular 20, 40, 50, 60 and 100, keeping that value constant, and then we are applying the same steps. We see 1, 2, 3, 4, 5 volt, like that this particular graph is appears. This is about the input and output characteristics. At the last characteristics is a transfer characteristics. Is similar to the emitter common emitter characteristics. So it is drawn between input current versus output current. So what about the input current here? IB. What about the output current? IE. Now we are going to draw the, initially which parameters should be constant here? VCE is the constant. VCE, because that is output. VCE constant. Initially IB is equal to 0. That is a input terminal should be open circuited. Then some leakage current will be flowing. Okay, this is a leakage current. So after that the graph will be like that. Okay, this is the characteristics of transfer characteristics, same as common emitter configuration. This is about the characteristics of 3 configurations. I hope that everyone clear about these 3 characteristics of a transistor. Okay, in the next class we are going to discuss the remaining topics. In this particular chapter, transistor characteristics and approximation, we in the second and third, within the 3 videos we are going to complete this particular chapter. Thank you.